Good day, everyone. I'm Venkat Swaminathan, and I'm excited to welcome you today to the episode of Encora Talks, where we talk of OTA updates or over-the-air updates for connected vehicles today. And in the next 30 to 35 minutes, we will explore some of the core building blocks of OTA platforms. We'll take a look at some of the technologies and drivers, and we'll cover some of the areas. And before we begin, I want to do a quick introduction. So, I serve as a senior director for automotive and manufacturing at Encora. About 25 years of experience in software and technology. Started working with back propagation networks in Fortran, and today I run the solutions and solution engineering teams for automotive and manufacturing. I get to work with some of the major OEMs and tier ones on their connected solution strategy. So, with that introduction, let's jump right into the session. So, what we'll cover today are really we look at the following areas. We look at what is OTA about? What are some of the connected ecosystems? How is OTA or over-the-air updates? OTA stands for over-the-air. How it's being used? What are some of the industry trends that are driving the capabilities? We'll also look at some of the use cases, how AI and all of the trends that you see today around AI and GenAI are going to help. And we hope that at the end of the session, you will get some new insights or ideas that you can take forward in your respective area of focus. So, what are some of the industry overview? What is the industry talking? One of the key drivers of the trends in connected platforms is consumer expectations of how a car should behave. We're all used to phones, and we want that seamless experience that we carry our mobile phone with us, and that's really one big driver. So the capability of providing a seamless experience across the mobile device, the connected home, and the connected car is one of the primary objectives for most OEMs. That's really what they're trying to do all the time. And in fact, if you look at some of the surveys, we see that customers are willing to pay for connected features. This is just an example of one market survey where it shows the propensity for consumers who are willing to pay for connected features in different global markets across the world. There are a lot of other surveys that kind of support this. People will pay. But the question is, what are they going to pay for? What are the features that are most important for them? And like we started off saying, it's all about the experience that defines the brand. It defines how customers see your vehicle, see your brand. And the key is, I want to be able to take my mobile phone and whatever experience I have on my phone, I want to be able to translate that into the car. And that's really what is driving it. So everything that when we talk of the connected vehicle, we talk of the updates to a connected vehicle, it's around driving that customer experience and supporting that ecosystem of connected devices. So, what is this connected ecosystem that we talk about? I think before we get into discussing the connected platform and how OTA enables that, it's probably worth spending some time on trying to understand what is this connected ecosystem and how the platform is supposed to, what is this platform that is supposed to work with that. So let's take a look at that. And we'll spend some time here. So at the center of the connected ecosystem is the connected driver with the connected vehicle. When we say the connected driver, we're talking of the mobile phone, watch, and all of the other devices that we have. I wear a watch, I carry a phone that's connected, and I want that to interact. And the most common example is you go in and you sit in a car and you pull up maps for directions, or you pull up your Spotify playlist, and you're now connected to everything. But one of the experiences, and if this is especially true if you're working in the power sports or you're driving a exciting car or a two-wheeler, is you also want to share with other drivers. So there's a community, and that community works both ways. You want to share your experiences with the community, and the newer generation of consumers are going to social media and their communities to make buying decisions. So it's important that OEMs now extend the connected ecosystem to just not the car and the driver, but also to build out those digital channels that go across communities, whether it's like Facebook or Instagram or any of the other, whatever is the currently popular community. And it's important that you monitor, manage, and enable people in this community. So that becomes key. The infotainment system or the display, the heads up displays inside the cars, become the platform through which you deliver that experience. So the audio and video elements of the experience become the key channels. So it can be as simple as maps or alerts or notifications that are considered table stakes today in today's devices. The ability to project your phone wirelessly onto the display is what everybody expects. But the whole concept of digital cockpit, where the car is able to interface with the driver using voice commands, using gestures, using personalized recognition, becomes key. So these, if you look at the layer in the middle, the digital channels, the connected driver, the displays, they become the platform through which the experience is delivered. But supporting that is a whole series of third-party providers which support the underlying infrastructure, whether you're pushing updates to your car, you're providing geofencing capabilities, you're providing the technology services that allow you to remotely start, stop, manage your climate control, call for help if you're stuck on the roadside. And then as you go to the right, you integrate with smart cities and smart parking, smart garages. When it comes to electric vehicles, smart charging, all of those become key players. So the connected vehicle now suddenly it's just not about the driver, but it's going across to the entire public infrastructure. And at the base of all of this, it's the OEMs that are also interested and are invested, along with their ecosystem of dealers, support, marketing teams, the IT teams that take all of the data and enable that personalized customer experience, so that when you go to a dealer, the dealer already knows what you're here for, can plan for it. The car can talk to the dealer systems to set up appointments. All of those are becoming real. So as you notice, the connected ecosystem starts with the driver and the vehicle, and then extends to just going beyond the technology and going into experiences that bring into play a lot of other actors, like the dealers and the state and the city and so on. And the connected platform needs to enable that. So now that we know what we are trying to support, we look at how do we go about it. So what is the whole connected platform? We look at some of the capabilities and we'll start looking at how we'll dive a little more into it. It's a little hard to read. I apologize for that. There's a bit of a color issue. But essentially, on the left, you're seeing a set of disruptors. What we mean by disruptors are really drivers of change. We use drivers in a different context, but the software defined car or the software defined vehicle or SDV, as you've heard it, becomes that vehicle or the vehicle through which all of this is delivered, and that requires, and all of these require OTA updates. When you talk of advanced driver assistance systems, smart cruise, lane changing, automatic speed sign recognition, and so on, that a lot of us are getting used to with our electric cars or with the newer generation of cars, they need OTA updates. Autonomy is something we are all aspiring for. The industry is going through different cycles of calibration on levels of autonomy, but it's coming. And whether it's ADAS or autonomous, you need all of that. The software-defined vehicle provides that. Electric vehicles are what triggered all of this, but the capabilities and the features that electric vehicles brought into play are now coming into the traditional vehicles, the gasoline vehicles or ICE vehicles, as we call them. The additional thing that with ICE vehicles is there is a need for maintenance. So intelligent diagnostics, predictive diagnostics, where the vehicle can automatically figure out, hey, I'm coming up for, as simple as I'm coming up for an oil change that's based on time, to I'm looking at some of the data that's flowing through my CAN bus, and it looks like I might need to replace that particular component. So let me talk to the dealer systems and set up an appointment or let me notify the driver, those become critical. And in today's economic world, where cost is a major factor, the need to keep maintenance costs down, to keep the overall cost of ownership down, becomes a key driver. So customer expectations is something we already talked about, where customers want more and more features in their car. You want the car to play your Spotify list. You want, if you're taking the children out for a summer break, you want Wi-Fi in the car, but you don't want to pay for Wi-Fi all the year. So you want to be able to subscribe to features on demand. You just want it for the summer months. You just want it for a road trip, but you don't want it the other times. OEMs are talking about going to new markets. Um, you know, the world is growing in terms of market size. There are more and more people now looking to buy cars, and with that come new regulations and new expectations and new customer behaviors that OEMs have to prepare for. And all of that comes with the need to improve the technology, the communication architecture inside the car, which is, which has to keep up with the huge volume of data. Now we have cameras and all kinds of sensors inside the car. And one of the most important things is security. Anything that's running software, that's relying on a connected network, that is exposed to an uncontrolled environment is a target. So it's very important that cybersecurity is key, so that there is no you protect the environment within the car. So these are all enabled by over-the-air software updates, because all of these are going to continually change. When you take a car from region 1 to region 2, you're going to have a new set of regulations, new set of expectations. So you need to send updates over, because you can't bring the car back in to fix each time. That's very yesterday. So the components that enable that, you see on the right, there is really the core platform that is enabling your over-the-air update, the OTA process, the OTA design that helps you manage the devices. And when you do an update, it's typically run as a campaign where a number of cars or a number of devices in a particular geography or a particular type of car or a particular model are updated. And it is important to monitor. I mean, it's very similar to how your phone updates today, or your computers, your desktop computers are updating. You get notification that there is a new update. It tells you whether you want to select it now or you want to update later. Sometimes the update doesn't go through. And if it doesn't go through, you're given a few options. But somebody is tracking somewhere that, hey, this system did not update, and we need to do something about it. In the case of a car, if it is like a security update, if it's a recall, then you can't just ignore it. You now have to, maybe as a last resort, bring the car in, which is expensive. So managing a campaign and reporting on it and trying to identify how far the campaign progressed, whether it reached its target, becomes very critical. And in managing the data and resolving some of the issues that arise from OTA updates, we are starting to use some of the data and intelligence tools, whether it's traditional ETL reporting or even new AI and GenAI based solutions that automatically identify, resolve, and direct the issues. They become solution approaches. So the solution platform, as we see, needs to support all of this: the OTA application, the device management. It needs to be able to manage the workflow for the whole campaign. And at the back end, it needs to make sure that the people running the campaigns have all of the dashboards and the reporting to enable that. The goal of all of this is about making it as non-intrusive and as seamless for the end consumer. Ideally, you should not know it is happening. You park your car in the evening, you go to bed, the update is happening. When you come back in the morning, you get a cool new feature. That's a desired objective. There are privacy laws and security laws that require your consent. So consent management, all of that is built in. We're not going into a lot of that, but what I'm trying to tell you is here that the process, everything that we're talking about, is about making that experience for the consumer as seamless, as non-intrusive, and they're only seeing the benefits and none of that. So that's really what the solution platform is about. Let's go a little more into detail. On the left, you see that what we are talking about is the platform, is the physical devices or the assets that enable this. Whether it's farm equipment, whether it's drones, whether it's vehicles, power sports, two-wheelers, they are the targets, they are the devices. And those devices, and the devices could be the car, or depending on what we are talking about, it could be the modem inside the car, it could be the telematics unit inside the car, it could be the transponder, whatever it is. Those are the devices that have to be monitored, whether they're connected, are they running low on battery, so that are the conditions okay for updates, and they need to be managed. New devices come in. When you sell your car to somebody else, there's a whole new set of policies. We need to do some cleaning. We need to register the device to a new person or a new entity. There got to be reprovisioning. The new person has a different set of subscribing features they're subscribed to that you have not, and so on and so forth. So the devices need to be managed. The next layer on the left, you're talking about the networks and the cloud platforms that enable all of this. Typically, cars are connected through a 5G or a 4G modem that they have a SIM card, or they have an eSIM that allows data to connect. If they're sitting in your garage, they may connect over Wi-Fi. For some of the basic devices, we may use the tethered phone as a connectivity platform. But there is some kind of public network or some kind of third-party wireless network that the device is using to connect. And then inevitably, that connection goes to some kind of a cloud-based platform. It's going through a CDN into a cloud platform. And what happens on the cloud platform is really a lot of the core technology that we talked about. The device management on the cloud side now makes sure that you're connecting to the right device. There is a secure channel of communication. The device is registered. It's not being hacked. Its integrity can be verified. There is a whole telemetry aspect. If you're looking for things like geofencing, if you're driving your car too fast, or you're driving your car beyond a restricted area, this is applicable for multiple use cases. Rental companies. So if you're renting a car and the rental company says you cannot take it outside this particular region, it could be a state, it could be a country, it could be some kind of border, then you're talking of telemetry. But at a more personal level, you can enable geofencing for your own car if your child or a family member is taking out and there are curfew times or curfew zones, or there are some restrictions if you have a new driver in your family and you don't want the car to be driven too rashly. Then you can set up those controls that rely on telemetry to enforce those experiences. On the cloud side, when you say telemetry, there are two aspects. One is making sure the data is transferred in an integral fashion between the car to the cloud. But then once it comes on the cloud, it needs to be brought into your data source, your data repositories, your data lakes, or whatever data stores you have. And that needs to be stored, tagged, enriched with other historical data. In some cases, if you're sharing data with third parties, then you need to anonymize, or you need to remove any you may want to remove identifiers. So there's different types of enrichment. When I say enrichment, I'm covering a broad class of activities, all the way from anonymization to augmentation to all of that. But all that needs to happen, and a lot of those need to happen in real time. So you have technology platforms, the Kafkas, the MQTT brokers, all of that, and the different types of architectures that enable the real-time streaming, analytics, and processing. And then there's policy management. What kinds of data is allowed? What is, if there's any personal information that needs to be anonymized, so on and so forth. So all of these are running all the time on the cloud platform, on the server or cloud platform, as they call it. But that's enabling, and you're talking of millions of vehicles. You're talking of 10, 12, 15 million vehicles globally at any point running on this. And then all of the data we talked about, there is a whole suite of integration that needs to happen across the enterprise. If your vehicles is sending data about an impending issue with a component that is likely to fail or likely to give a problem or resulting in some kind of warning, that then needs to be taken and maybe notified. If you have given your appropriate consent, then maybe let the dealer know that, hey, this vehicle is looking like it may need maintenance. There's a maintenance event coming up. dealer, here is a maintenance event, this is your preferred dealer, and initiate that. So that's an example of what the integration might result in. Analytics results in a whole set of maybe warranty issues, or is this any kind of pattern that we are seeing on the enterprise level? And we cannot ignore some of the advantages, some of the advances that are happening. Gen AI and the trends in AI and ML are changing the way we approach this. More than changing, they're enabling a lot of things that were earlier not easy to do. So we cannot ignore that, but it very judiciously applies some of these to some of those use cases. And we'll talk about some of that. And the way people use this are through dashboards or APIs and actionable insights and some of the intelligence that's actionable. So in order to realize the customer use cases that require all of these things that we talked about, low latency, telemetry, the vast volumes of unstructured data, we do want to ensure that these dashboards, the right APIs, the right data, cleansed data, all of these are available. So collectively, if you look from left to right, you're looking at how you're taking the data from the end devices through the different components and into something that is actionably used. So let's look at what are some of those use cases we talked about. The use cases span different types. So on the left, you see some of the technology elements that enable these use cases. Some of these have existed for a while now. Some of these are relatively new. But collectively, and it's not just a piece of hardware, we are talking of the technology and changes or the technological, how do I call it, technological ideas or concepts that are in place. Things like GPS, 4G, 5G connectivity have been around. But what you're seeing more and more today is things like GPUs and high compute elements getting into the car. When you talk of something like remote ops, it's as simple as like when I got off a plane last night, as I'm walking from my gate to the parking garage, at some point, I know, based on which airport I am in, if I'm at home, I remotely start the car. So that I know by the time I get to the car has reached the right temperature that I want it to be. And I live in Atlanta, so a lot of you know what I'm referring to when I want to remotely start the car in summer. Diagnostics is a key thing. It's not all of the data that's flowing through a car has got to be useful for something. So what's happening is as you're able to bring in edge AI or push machine learning models into the edge because of the compute and network and data bandwidth available now, you can now run diagnostics on the edge. Now the car can come in and say, rather than just giving you an error code or the check engine light that turns on, the car can also be a little more proactive and says, I think you need to go into a dealer, have this looked up, and the dealer can pull up more information. Looks like the oil temperature was a little too high over the last few drive cycles. So what does that mean? And then there are different levels at which this can operate. We talked about IT security. There's a lot of information. If you go, there was a time when vehicles were not as well protected. People hacked it. It was easier to hack. And when people did that, it became a big public event, and nobody wants that kind of public event. So IT security, putting security gateways inside the vehicle, signing the different messages. There are different levels at which cybersecurity works inside a vehicle. There are different ISO standards, and it's standards that apply to how you're going to secure the vehicle. Electrification, you cannot ignore it, as electrification has changed the way people look at vehicles, the way people drive vehicles, the things that they want the vehicles to do. So today when people go for a drive, mapping your route or looking at charging stations and all of the stuff that comes with it becomes almost standard, accepted, normalized behavior. So we need to account for that. The advances in AI have enabled a lot of advances in voice control. A major OEM recently announced like an intelligent voice control inside their car with the app. So now you can talk to the car from basic commands to doing a lot of things that require you to go through menus and push buttons. You can engage with the car, and that's That's becoming key, and a number of different OEMs are working towards it. Autonomous driving, or the levels of autonomy or ADAS that we are talking about, become key. When I drive my car today, I'm so used to kind of taking advantage of some of these features, whether it's smart cruise or intelligent lane changes. This is something that is enabled. We don't know a lot of the underlying technology that's enabling this, and that's how it should be. I should not have to worry about which model is looking at the street lights or which model is planning my lane change. It just works. Location services that enable you to uh, identify whether a parking spot is available, or what automatic tolling. A lot of countries have actually started doing GPS based tolling. So gone are the days when you go up to a toll booth and throw coins into it or pay cash. Then came transponders, which is the vast majority of places. You have a little transponder stuck on your car. As you go through, it charges it. But even the next level is GPS based. So now I can actually, you're not fixed. You're charged on the actual use of the road. You can take any exit you want. You can enter and leave any place, and you're charged for exactly what you used for. That's actually there in a lot of countries. So the use cases all typically drive around that. Anything which is related to cybersecurity uh, requires all of this. The software-defined vehicle has become a concept, has become this vehicle that allows you to get that experience. The closest analogy is again the phone that you have. And what I like to tell people is everybody goes to an Apple or an Android a phone store, they buy exactly the same phone. When you buy a current model of an iPhone or an Android based device, you are buying the same phone as a million other people are buying. But in a matter of a day or a week or hours, your phone looks and behaves very differently. No two phones look alike. You take your phone and you take another phone of the identical model, identical brand from somebody else, the phone looks completely different. The icons are different. When you click on it, it does something different. It sounds different. It looks different. It behaves different. That's because you customize it to your preferences. What is your preferred apps? The software defined vehicle is the analogy to that, where the vehicle now is personalized to you. So you might buy a particular type of physical device from an automotive store, but by the time you start driving it, it looks very different. And we talked about how this difference happens. The predictive diagnostics, the vehicle can now respond back to you. It can talk to the dealer. It can proactively identify failure points, and that helps the OEMs optimize their warranty programs. On the side of the OEM, being able to identify warranty events in real time rather than based on static rules is a huge benefit to optimize warranty spend and any leakage issues. Inspection today, you when you return a rental car, some of us are used to having that rental agent walk around the car, check for damages. It's all a matter of driving up, a camera takes a look and identically and instantly identifies any damages or any issues. We talked about cockpit AI, where the AI inside the car drives the engagement with the driver. So when you look at all of these use cases like EV fleet management, how many, which car, whether the cars are all charged and ready to roll, and at the back end, it's about making sure the enterprises have the tools to manage all of the data and drive those intelligent decisions. There's tons of data coming into the back end, and they need to be managed. So these are the use cases that are a consequence or a driver of the software-defined vehicle and that OTA enables. So as we get to summarizing what's happening, there are a few key takeaways, and I want to wrap this up with summarizing some of the key takeaways. The first thing that we harped on is consumers want a personalized and unified experience across all of the touch points. Whether it's the home, your connected home, your devices at home, whether it's your phone, your car, you want that experience to translate and transfer from one device to another in a unified and seamless manner. And that means automotive OEMs are now facing challenges, new challenges that now become opportunities. How do I provide that experience? How do I integrate and meet those expectations of customers? And they must adapt to it and incorporate that and respond to that. And they're using all of the latest technology platforms, GenAI, Edge AI, Edge computing, high performance computing. All of those are becoming critical. And to enable all of that, over the air updates become a critical component on how you deliver that experience, that digital cockpit experience to consumers. So, with that, I think that's all I wanted to kind of summarize here. I want to see if there are any questions uh, from the audience that we can take at this point. So, if there are any questions, we will take it. So, first question I see here is, how is GenAI impacting OEMs in terms of their plans to roll out features? What challenges should they plan to address? So, like we spoke about, GenAI is now enabling OEMs to rapidly roll out things that would have taken a lot of time, right? Things that took, as an example, if there is some catastrophic event, there is a wildfire, or there's a weather event in a particular area. OEMs want to know how can they reach out to their affected consumers and what can they do for them. Traditionally, it takes a long time to get the data, to get the subscriber data, map it by region, and figure out. GenAI makes it a lot easier. So the challenges that they now come into, that they're starting to address, is how do I now use these new technologies like GenAI that everybody seems to talk about, but how do I make it work for my business case? How do I get business value out of it? So the challenges are making sure I identify the business value out of anything new. It's very easy to get tempted by new technology, but always keep in mind what you're trying to do. So making sure you have a business use case, a business value defined, allows you to take in all of these new tools and new technologies and use it in a measurable manner. Hope that answers it. Any other questions? How can OEMs monetize the data that they are now able to capture via telemetry and subscriber behavior? Data monetization is something that OEMs have been chasing for a long, long time, with varying degrees of success in varying areas. The key to realize is the data is valuable. The data is what, in today's models, in today's paradigms, it's all about the data. In the previous generation, apps were central and apps generated data as an output. In today's world, data is at the center and apps are built around the data. So when you look at it from a data perspective, the key to realize is what are the insights, the actionable insights, or how do I make this data valuable? And who are the parties valuable? And then how do I do this in a regulated manner, because you don't want to randomly sell PII data and get into all kinds of trouble. But the monetization is based on compliance to regulations, on time, because data ages. The longer the data sits in your database, the less valuable it becomes. The sooner you can translate that data to something of value, to something of use, its value goes up. So the speed to getting the data to the end user is critical. So for monetization, you need to focus on making sure it's appropriately managed, getting it quickly, and tracking it effectively. So those are some of the things that we talk about when we talk to OEMs. I think maybe time for one more question. Okay, we have one. We have heard of V2X, vehicle to everything connectivity. What are some of the real world applications or benefits from V2X connectivity platforms? Here's something that we don't even realize is happening, but it's happening in a lot of vehicles. So a lot of times you might have seen, as you're driving down the highway or the road and you're running Google Maps or whatever is your mapping software in your car, you get a notification saying there's a vehicle on the roadside, stalled vehicle ahead or something like that. What we may not realize is a lot of times that data is coming from the vehicle itself. So some of the models from some of the OEMs have the ability to, if you're pulled over on the side of the road and there is a hazard situation, the vehicle can automatically notify that I'm in trouble, not just for getting help. So it can go to the agencies, it can go to the first responders, but it can also go to the map providers and the traffic data systems, so that now an alert goes out. And this is being used in a number of different ways. If there are emergency vehicles coming up, they can now broadcast saying there's an emergency vehicle coming up. It lets the other vehicles know. Think about street lights, and some of the V2X connectivity now enables the vehicles ahead to notify the vehicles behind of any hazards in the road, or anything. There's something fallen on the road, or the traffic light alert, or there is an obstacle, or pedestrians, or whatever. This is increasing, and there are partnerships between telecom network providers, cities, vehicles, OEMs to bring this all together. So there's very tangible benefits that you're actually starting to see. And I think that's all. We don't have any more questions. So with this, it's a wrap for today's session. I want to thank everyone. I want to express my gratitude to each of you for joining us on this webinar today. And for more insightful content, please subscribe to our YouTube channel at Encora Inc. You'll find a lot of treasure trove of webinars. There's a lot of material. And for more updates, please do visit us at www.encora.com. Thank you so much.